Welcome to Grade 10 Mathematics Classroom. Today we are going to continue the previous lesson, Angles in a Circle, that is the 31st lesson in your mathematics textbook. Right. Previously we have discussed on 3 theorems related to angles in a circle. So today we are going to do some questions related to those 3 theorems. Right. Before moving to the questions, I thought of recalling the memory that we have learnt in previous lesson. Right. As I have told you, we have discussed on 3 theorems. First one was the angle subtended at the center of the circle by an arc is twice of the angle subtended on the remaining part of the circle by the same arc. Then we have discussed on the second theorem, that is the angles in the same segment are equal in magnitude. Finally, we have discussed on the angles in a semicircle, and we said that the magnitude of the angle in a semicircle is 90 degrees. Right. Now, those are the 3 theorems we have discussed in the previous lesson. Right. Now, today we will go through some questions related to those 3 theorems and some more questions related to proofs. This is my first question. We will have a look at this question. Right. Find the magnitude of the angle denoted by the English letter. Right. Here they have mentioned that BD is the diameter of this circle. It is a diameter. So, we have got 4 English letters to find the magnitude: A, B, C and X. Right. So, we want to get the magnitude of those angles. Therefore, we will take one by one. First, we will get the magnitude of angle A. Previously, we have learned that the magnitude of the angles in the same segment are equal. Right. Now, when you look at the question, you can see the magnitude of angle ADB and the magnitude of angle ACB should be equal. The reason is both angles are on the same segment. So, angle ADB is denoted as A and they have mentioned the magnitude of the angle ACB, that is 55 degrees. Therefore, we can say the magnitude of A is equals to 55 degrees. Right. Now, we have got the value of A. We have to find the value of another 3 letters. Those are B, C and X. We will take another one. Right. Next, we will find the magnitude of C. Here, can you see, when we consider about this triangle, here this angle is 100 degrees. Therefore, we can say C plus 55 degrees should be equals to 100 degrees. The reason is the magnitude of an exterior angle is equals to the sum of the interior opposite angles. Right. Now, this is the exterior angle, the magnitude of it is 100 degrees. These are the interior opposite angles. So, we can get the sum by adding these 2 values. So, C plus 55 is equals to 100. Now, once again we have constructed a simple equation. By solving this, we can get the value of C. Therefore, I am going to subtract 55 from both sides. C plus 55 minus 55 equals 100 minus 55. So, I can get the value of C by subtracting 55 from 100, that is 45 degrees. Right. By now, we know the value of A, then the value of C. Right. Next, we will go for another letter. This time, I am going to find the value of X. Right. Now, what can you say? Here, when we consider about the angle DAB, what can you say about the angle? In the question, they have mentioned that BD is a diameter. Therefore, angle DAB is an angle in a semicircle. So, previously we have learned that the magnitude of the angle in a semicircle is 90 degrees. Therefore, the magnitude of the angle DAB should be equals to 90 degrees. So, DAB angle consists of two parts, 45 degrees and X. So, we can say X plus 45 is equals to 90 degrees. So, once again we have constructed a simple equation. So, by solving this we can get the value of X. So, now I am going to subtract 45 from both sides. So, X plus 45 minus 45, that becomes X. 90 minus 45, that is 45. Therefore, I can get the value of X as 45 degrees. Right. Now, we know the value of X as well. Right. Then, we have to find the value of B. Right. Now, since we know these two are vertically opposite angles, since this is 100 degrees, this angle should be equals to 100 degrees also. Therefore, we can consider this triangle, and we know that the sum of the interior angles of a triangle is equals to 180 degrees. So, when we add the magnitudes of these three angles, we can get the sum of the interior angles of the triangle. So, I can get 45 plus 100 plus B equals 180 degrees. That means B plus 145 equals 180 degrees. I want to get the value of B, therefore, I need to have B alone in one side. Therefore, I am subtracting 145 from both sides. So, I can get the value of B as 35 degrees. Right. Now, we have got the values of A, B, C and X. Right. We will move on to another question. Find the magnitude of the angles denoted by the English letters. Now, here in this question, we have got A, B, C and M to find the magnitude. Here also they have mentioned C is the center of this circle. Right. We will take one by one. I have just taken a part of this diagram. Now, here I can see AOB angle is equals to 118 degrees, and I can observe AOB is the angle subtended by the minor arc AB at the center of the circle, and at the same time I can observe ACB is the angle subtended by the same minor arc AB at the remaining part of the circle. Right. That means previously we have learnt a theorem as the angle subtended at the center of the circle by an arc is twice of the angle subtended on the remaining part of the circle by the same arc. Right. Now, we can relate that theorem to this question. Now, this is the angle subtended at the center of the minor arc AB. Using the same minor arc AB, we have the angle subtended at the remaining part of the circle. So, we can get it as twice of A is equals to 118 degrees. So, that means 2A is equals to 118 degrees. To get the value of A, we can divide 118 by 2. Therefore, the answer for A is 59 degrees. Right. Now, we know the value of A. We will move on to another one. Now, this was the diagram we earlier had. Now, I have substitute the value of A. I have taken off A and I have put the value of 59 degrees there. Right. Now, we will take another part of this diagram. Right. Using this, I am going to find the magnitude of C. Right. Here, I can say the sum of C and 90 degrees is equals to 118 degrees. Why is that? Previously, we have learnt a theorem as the magnitude of the exterior angle is equals to the sum of the interior opposite angles. Now, this is the exterior angle. These are the interior opposite angles. Therefore, I can get C plus 90 degrees is equals to 118 degrees. So, we have gained a simple equation. So, by solving this, we can get the value of C. Therefore, I am going to subtract 90 degrees from both sides. So, it becomes C plus 90 minus 90 equals 118 minus 90. From that, we can get the value of C as 28 degrees. Right. Now, we know the value of C as well. The magnitude of C is equals to 28 degrees. Right. Now, I will substitute that value as well. Right. We will get another one. This time, I am going to find the value of M. Right. Now, have a look at this triangle. Now, we know this angle is 90 degrees. This angle is 59 degrees. Now, once again, we can use the same theorem that we have used in previous session. That means to find C. What is the theorem? The magnitude of the exterior angle is equals to the sum of the interior opposite angles. Therefore, this is the exterior angle. These are the interior opposite angles. Therefore, we can say M plus 59 degrees is equals to 90 degrees. By solving this equation, we can get the value of M. Therefore, I am going to subtract 59 from both sides. M plus 59 minus 59 equals 90 minus 59. Therefore, the value of M is equals to 31 degrees. Right. Now, we have got the value of A, C and M. So, I will substitute the value of M as well. So, finally, we have to get the value of B. Therefore, we will take another part. Right. Now, here we can see AOB triangle and it is an isosceles triangle. Why is that? AO and OB are radii of the same circle. Therefore, AO is equals to OB. That means AOB is an isosceles triangle. So, we can say angle OBA should be equals to angle OAB, since it is an isosceles triangle. So, using that we can get the value of B. So, instead of angle OAB, I am going to name it also as simple B, right. Now, once again we know that the sum of the interior angles of a triangle is equals to 180 degrees. Now, I know all three angles in this triangle, therefore, I am going to get the sum of it. B plus 118 equals 180 degrees. So, B plus B becomes 2B. 2B plus 118 equals 180 degrees. Therefore, now we have constructed a simple equation. By solving this, we can get the value of B. So, first of all, I am going to remove 118 from my left hand side. Therefore, I am subtracting 118 from both sides. So, 2B plus 118 minus 118 equals 180 minus 118. So, I can get 2B equals 62. So, to get the value of B, I can divide both sides by 2. So, I can get the value of B as 31 degrees. Now, we will move on to solving problems using proofs. Right. In these problems, we have to prove the things that they have asked us to prove. That means, the final answer is given here. We have to prove that those are right, or some occasions they says show that it is wrong. So, you have to prove what they are asking for, right. So, we will move on to some questions quickly. So, we will then you will understand what I am discussing about, right. Now, this is my first question related to proofs. O is the center if angle AOC is equals to angle ABC, show that angle ADC is equals to 60 degrees, right. Here in the figure we can see a circle with center O, and 4 points are marked on the circumference of the circle. Those are A, B, C and D, right. This says that angle AOC is equals to angle ABC, right. If I am going to use a letter for angle AOC, I have to use the same letter for angle ABC, right. Once you look at this question, what can you observe? If I name the angle ADC as simple A, can you see a relationship between angle ADC and angle AOC? Previously, we have learned that the angle subtended at the center of the circle by an arc is twice of the angle subtended on the remaining part of the circle by the same arc. So, here we can say ADC is the angle subtended on the remaining part of the circle by the minor arc AC, and AOC is the angle subtended at the center of the circle by the same arc AC, right. Therefore, if ADC is equals to simple A, what can you say about the magnitude of the angle AOC? It should be twice of it. So, we can name the angle AOC as 2A, right. So, we will write it, we will write the proof. Angle AOC is equals to twice of the angle ADC. So, we can say it equals to 2A. So, when we are writing the proof, we have to mention why we have used this relationship. Therefore, you have to mention, that is, the angle subtended at the center of a circle is twice the angle subtended on the remaining part of the circle. You have to write the reason. Right. Now, have a look at angle AOC and angle ABC. What can you say about those two angles? Yes, those two angles are also same in magnitude. The reason is that is given in our question. So, we can say angle AOC is 2A. Therefore, angle ABC is also equals to 2A. So, we can write it angle AOC is equals to angle ABC, that is equals to 2A. The reason is its data, that means, or else you can write it as given. Right. Now, we have got two relationships. So, we will see both relationships are equals to 2A. Now, what I am going to do is, I am going to consider about the AOC reflex angle. Right. When I consider about the AOC reflex angle, that is equals to twice of ABC angle. We already know that the magnitude of ABC angle is taken as 2A. So, twice of it should be equals to 4A. So, reflex angle AOC is equals to 4A. Now, that is the next relationship we can get. Right. There also we have to mention the reason, that is, the angle subtended at the center of the circle is twice the angle subtended on the remaining part of the circle. Right. So, we can say 2A plus 4A is equals to 360 degrees. How did we get that? Here around O we have got 2A and 4A. So, when we are adding these two means it is the angle around a point. So, we know that the sum of the angles around a point is equals to 360 degrees. So, we can get 2A plus 4A equals 360 degrees. You have to mention the reason, sum of the angles around a point. Right. Now, we have got a simple equation. By solving this simple equation, I can get the value of A. So, we will simplify it. 2A plus 4A means 6A. 6A equals 360 degrees. So, to find the value of A, we have to divide both sides by 6. So, 6A divided by 6 is A. 360 degrees divided by 6 is 60 degrees. Therefore, the value of A is 60 degrees. So, we know that we got A as the angle ADC. Therefore, we can say angle ADC is equals to 60 degrees. So, that is what we have asked to find in this question. So, we have shown that angle ADC is equals to 60 degrees. Right. That is the end of the first question related to proofs. We will move on to another question. Right. Have a look at this figure. O is the center of the circle. Show that angle AOC is equals to twice of angle BAC plus angle BCA. Right. Now, they are talking about the angle AOC. We have to show that it is equals to twice of angle BAC plus angle BCA. First of all, we have to identify the angles they are asking for. Right. We will move on to the proof. Right. If I take the angle BOC as 2A, I can see that that is the angle subtended by the arc BC at the center of the circle. That means BOC is the angle subtended by the minor arc BC at the center of the circle. At the same time, I can observe that BAC is the angle subtended by the same minor arc at the remaining part of the circle. Therefore, if BOC is equals to 2A, we have to say angle BAC is equals to A. Right. Using this relationship, we will write it in the proof. Now, we can write the proof as angle BOC is equals to twice of angle BAC. So, there also we have to mention the reason. Before that, we have to mention the amount we have used using the letters. So, that is 2A. So, we will write the reason. The angle subtended at the center of a circle is twice the angle subtended on the remaining part of the circle. Right. Now, we have got a relationship between angle BOC and angle BAC. Right. Next, we will consider about the other side. Now, if angle ACB is considered as B, what can you say about the angle AOB? Angle AOB is the angle subtended by the minor arc AB at the center of the circle, and angle ACB is the angle subtended by the same minor arc at the remaining part of the circle. Therefore, if it is angle ACB is considered as simple B, angle AOB should be considered as 2B. So, we will write the relationship. Angle AOB is equals to twice of the angle BCA. So, that is equals to 2B. So, we will write the reason. The angle subtended at the center of a circle is twice the angle subtended on the remaining part of the circle. Right. Now, we have got another relationship between angle AOB and angle BCA. Right. Now, we have got two relationships. Now, what I am going to do is, I am going to add those two relationships together. That means, I am going to add the two equations together. So, I can get angle BOC plus angle AOB is equals to twice of angle BAC plus twice of angle BCA. Right. So, we have got that relationship using axioms. I have add the two equations I have got previously. Right. Now, when we consider about angle BOC and angle AOB, I can say it's equals to the angle AOC. So, instead of angle BOC plus angle AOB, I can write angle AOC and then I have got 2 in common, 2 into angle BAC plus angle BCA. So, that is what they have asked us to show in the question. So, we got the relationship of angle AOC equals to twice of the sum of the angles BAC and BCA. So, that is the end of the second question that I want to discuss with you related to the proofs. So, we will move on to another question. Right, have a look at this question. Right, the figure is given. If AB is equals to AC, show that angle CDX is equals to twice of angle ABC. So, first of all, we will see what these two angles are. Angle CDX is equals to twice of angle ABC. Right. Now, using the knowledge we have got about the three theorems we have learnt in the previous lesson, we have to show this relationship. So, we will move on to the proof. Before that, I will get part of this figure to make it much more easier to understand. Right. Now, I have got the angle BAC as A. Right. And they have given that the length of AB is equals to length of AC as well. Right. Now, when we consider about A, are there any more angles with the same magnitude? We will see. Now, we can see angle BAC and angle BDC are on the same segment. So, if I take angle BAC as simple A, I have to get angle BDC also as simple A. That means those two angles are equal in magnitude. So, we will write the proof. Angle BAC is equals to angle BDC, that is equals to A. So, we have to write the reason. Angles in the same segment. Angles in the same segment are the same. Right. Now, once again have a look at the figure. This time I am going to consider about triangle ABC. Right. Now, it is an isosceles triangle, isn't that so? AB is equals to AC. Two sides are equal in length. Therefore, it is an isosceles triangle. Right. Therefore, if I name the angle ABC as simple B, I have to name the angle ACB also as simple B. The reason is we know that in isosceles angles there are two equal angles. So, we will name angle ACB also as simple B. Right. Now, we can have a relationship as angle ABC is equals to angle ACB equals to B. The reason is ABC is an isosceles triangle. Right. Therefore, we can say angle BAC plus angle ABC plus angle ACB is equals to 180 degrees. Since angle BAC and angle ABC and angle ACB are angles in a interior angles of a triangle. So, we know that the sum of the interior angles of a triangle is equals to 180 degrees. So, we have to mention the reason as well. So, we can say angle BAC plus here angle ABC and angle ACB. What can you say about these two angles? Previously, we got that those two angles are the same. So, instead of these two angles, I am going to name it as twice of one of it, because both are the same. So, instead of these two, I am going to write it as twice of angle ABC is equals to 180 degrees. There I have used axioms to write it as the relationship. Right. Now, I can say when I consider about the angle BDC and CDX, I can say angle BDC plus angle CDX is equals to 180 degrees. The reason is those two are the angles on a straight line segment. So, we know that the sum of the angles on a straight line segment is 180 degrees. So, we have to write the reason when we are proving something. Right. Once again, have a look at these two equations. First, we got angle BAC plus twice of angle ABC equals 180 degrees. Then I got angle BDC plus angle CDX is equals to 180 degrees. Right. In both equations, I have got 180 degrees in my right hand side. Therefore, I can get it like this. Angle BAC plus twice of angle ABC is equals to angle BDC plus angle CDX. I got it using the knowledge of axioms. Right. Since angle BAC is equals to angle BDC, I can subtract angle BDC from both sides. Since these two angles are equal in magnitude, when I subtract angle BAC from both sides, both the values get omitted. Therefore, I can get a relationship twice of angle ABC is equals to angle CDX. So, that is what they have asked us to find in our question. I got the relationship using the knowledge of axioms. Right. Then that is the end of this question. So, we will move on to another question. Have a look at this diagram. The diameter of the large circle is PSQ and the diameter of the small circle is SQ. Show that angle PRS is equals to angle RSX. Right. First of all, we will have a look at these two diameters. PSQ, that is the diameter of the large circle. SQ is the diameter of the small circle. They are asking us to show that angle PRS is equals to angle RSX. RSX. That is what we have to show. So, we will move on to the proof. So, I am going to take part of the figure to make it more easy to understand. Right. Now, we know that PQ is the diameter of this circle. Therefore, we can say angle PRQ is an angle in a semicircle. So, previously we have learned that the magnitude of the angle in a semicircle is equals to 90 degrees. So, we can use that knowledge here to prove. So, we can say, we can write the proof as angle PRQ is equals to 90 degrees. We have to write the reason, angles in a semicircle. Right. Now, once again we will move on to the figure. Right. There you can say about the small circle. There the diameter is SQ. So, what can you say about the angle SXQ? Once again, it is an angle in a semicircle. Therefore, the magnitude of the angle SXQ is 90 degrees. Therefore, we can say angle SXQ is equals to 90 degrees. Once again, you have to mention the reason, that is angles in a semicircle. Right. Now, we have got two relationships, both are equal to 90 degrees. Therefore, we can say angle PRQ is equals to angle SXQ. Right. We can get this relationship using the knowledge of axioms. Right. Now we will consider another part of this figure. Right, once again I have got a part of it to make it much more easy. Right, what can you say about angle PRX and angle SXQ? Those two are equal. So, we know that PR is parallel to SX. The reason is corresponding angles are equal. So, we got angle PRX equals to angle SXQ. So, we can consider those two as corresponding angles when PR is parallel to SX. Right. Now, when we consider PR and SX are two parallel lines, we can join RS. Therefore, we can say angle PRS is equals to the angle RSX. The reason is those two are alternate angles. So, finally, we got the answer. We got what they have asked us to show. Right. We will move on to another question. Have a look at the figure. PQ is the diameter of the circle with center O. QR is parallel to OS. Show that SR is equals to SP. So, first of all, PQ is said to be the diameter and this is QR is parallel to OS, and they are asking us to show that SR is equals to SP. Right. Now, we know what they are asking us to show. So, we will move on to the proof. Before that, I am going to go for a construction. That is, I am going to join S and Q. Right. Then we will move on to the proof. Once again, I have got a part of the figure for it to be more simple. So, here I have got the angle SRP as simple A. Right. Therefore, we know that angle SRP is the angle subtended by the minor arc SP on the remaining part of the circle. So, the angle subtended by the same minor arc SP at the center of the circle is angle SOP. Therefore, if angle SRP is equals to simple A, we have to take angle SOP as 2A, twice of A. So, we will write it in the proof. We can write it as angle POS is equals to twice of angle PRS. So, we have to mention the reason. Before that, we have to mention the value of it. We have got it as A, therefore, it is equals to twice of A, that means 2A. Therefore, we have to mention the reason. The angle subtended at the center of a circle is twice the angle subtended on the remaining part of the circle. Right. Now, we have got one relationship. Right. Once again, we will have a look at the figure. In the question itself, they says that QR is parallel to OS. So, I have mentioned that in the figure. So, we will write it in the proof. QR is parallel to OS, that is given. So, we can mention it as data. Once again, I have taken part of the figure to make it more simple. Therefore, we can say since OS and QR are parallel and since the angle POS is equals to 2A, you can say that the angle PQR is also equals to 2A. What is the reason? Those are alternate angles. right? Since OS is parallel to QR, and since the angle POS is equals to 2A, we can mention, and the angle PQR is also equals to 2A. The reason is angle POS and angle PQR are corresponding angles. So, we can write it in proof. Therefore, angle POS is equals to angle OQR. The reason is those are corresponding angles. So, we can write the value of it as 2A. Then we will write the reason. Right. Once again, we will have a look at the figure. Now, I have mentioned the total figure together. So, we have got some relationships up to now. So, we have to show that SR is equals to SP. We will see. Now, I did a construction. Now, I have mentioned the construction also in my figure. So, once again, I will get a part of the figure to make it much more easier. So, we know that angle POS is 2A. We have taken it by now. And we can observe that angle POS is the angle subtended by the minor arc SP at the center of the circle. And we can observe angle PQS is the angle subtended by the same minor arc PS at the remaining part of the circle. Therefore, once again, we can have a relationship between those two angles. Previously, we have learned that the angle subtended at the center of the circle is twice of the angle subtended by the same arc at the remaining part of the circle. Right. Therefore, angle POS is 2A. That means the magnitude of the angle PQS can be taken as simple A. So, we will write it in our proof. Angle POS is equals to twice of angle PQS, that is equals to 2A. Then we can write the reason. The angle subtended at the center of a circle is twice the angle subtended on the remaining part of the circle. Right. Now, we will get the complete figure. Now, we can say that angle OQS and angle SQR are same in magnitude. Therefore, we have to mention both as simple A. So, we will write it. Therefore, angle PQS is equals to angle SQR. That is equals to simple A. Therefore, angle PQS is equals to angle SQR, that is equals to simple A. Right. Now, I have get a part of the figure once again to make it more easy. Now, I can see angle SQR and angle SPR should be the same in the magnitude. The reason is both the angles are in the same segment. Previously, we have learned that the angles in a same segment are equal in magnitude. Therefore, if angle SQR is equals to simple A, we have to mention angle SPR also as simple A. Right. So, we will write it in our proof. And angle SPR is equals to angle SQR. The reason is, you have to mention the reason. Before that, the value of it is equals to simple A. So, we will mention the reason. Angles in the same segment. We know that the angles in the same segment are the same. Right. So, in our proof, we have got angle PQS is equals to angle SQR, that is equals to A. Then we got angle SPR is equals to angle SQR, that is also equals to A. So, using these two equations, we can get another equation as angle PRS is equals to angle SPR. Since both of them are equals to angle SQR, we can get a common relationship as angle PRS is equals to angle SPR. That is equals to simple A. We got this relationship using the knowledge of axioms. Right. Once again, I have got a part of my figure. Therefore, I have got the triangle SPR. We know that angle SRP is equals to angle SPR is equals to simple A. Therefore, I can get the triangle SPR as an isosceles triangle. So, we know that in isosceles triangle, two sides are equal in length. Here, the equal sides should be SP and SR. So, we will write it in our proof. Therefore, SR is equals to SP. That is what they have asked us to find in our question. So, the reason we have to mention those are isosceles triangle. Right. Now, we have proved our statement that they have asked us to prove. Right. So, that is the end of the last question that I need to discuss with you. Right. Now, in our previous lesson, we have discussed about 3 theorems. In this lesson, we have discussed some questions on those 3 theorems. So, before wind up the lesson, I will mention the theorems we have discussed. First one is the angle subtended at the center of the circle by an arc is twice of the angle subtended on the remaining part of the circle by the same arc. Secondly, we have discussed about the theorem that the angles in the same segment are equal in magnitude. Finally, the third theorem we have discussed was the angles in a semicircle are equals to 90 degrees. So, today we have done questions related to those 3 theorems and some proofs as well. Right. I think the lesson is clear for you, and if you have missed the lesson or if you want to go through the lesson once again, you can watch the lesson through the YouTube channel, Channel NIE. So, that's it for today. See you in another lesson. Take care.